We are looking for the derivative of big f of x. So we're looking for the derivative with respect to x, and the power rule will come handy, so I will write it here. So we know that derivative of x to the n with respect to x is equal to n times x to the n minus 1. If I look at my function, I see x to the power 12 here. This expression can be written as a power of x. So before I take the derivative, I will rewrite this square root of x, and this is a constant number. So f of x equals 2 over 3 x to the 12 minus x to the power 1 over 2 plus e to the power 19. So now let's take the derivative. I'll use the Leibniz notation. Derivative of big F with respect to x is equal to coefficient times x to the power. So coefficient stays. Now apply the power rule for x to the 12. So that means we're going to write 12 times x to the power 11 minus. Apply the power rule for x to the 1 over 2. So we'll have 1 over 2 times x to the 1 over 2 minus 1. Since that's not as quick as this, I write it. And then plus derivative of e to the 19. E is an irrational number just like pi. It is approximately 2.71828, and it has infinitely many decimal places, just like pi, but after all, it is a constant number. So if I raise e2 to 19th power, I find another constant. So I don't really apply the power rule for this because I'm taking the derivative here with respect to x, and this expression doesn't have any x in it. E is a constant number, and derivative of a constant is 0. Okay, so let's go ahead and simplify our expression. So 2 over 3 times 12 is the same thing as 2 times 4, which is 8, times x to the 11 minus 1 over 2 x to the power negative half. If you like, you can leave your answer like this, or you can write it in positive power as negative 1 over 2 times square root of x. Either answers are correct.